Hi, Algebra 2 friends. Here we are back in section 7.5, and we're looking at this situation that the text calls us to synthetically substitute to find all the zeros. And so what we are encouraged to do, and I honestly wouldn't recommend it. I mean, if I were like walking down the street and I had to factor this thing and figure out what the zeros were, I wouldn't recommend pulling out Descartes' rule of signs. I'd probably pull out a calculator. I mean, just to be honest. However, for the sake of the problem, I will honor what they're asking us to do, but we'll talk about some techniques later on that will circumvent Descartes' rule of signs in a way. Or we could use it with it to kind of get better. Okay, so Descartes' rule of signs says if we take a look at the function as it is and change the signs and see how many sign changes we have. So we've got one sign change, two sign change, three sign changes. So those three sign changes means that we either have right now three positive zeros or subtract two from that because we have, or any even number less than that is how it goes. Three or two, and these are positive zeros, okay? And then we can put in f of negative x, and when I do that, I get a negative x cubed. This stays a negative 4x squared. This becomes a negative 6x, and this minus 4 stays that way. So you realize there is no sign change. So what this says is that there is no negative 0. No negative 0 there. So now the next question is, how many imaginary zeros do we have? Okay, how many of those could we have? How many imaginary roots or zeros could we have? Realizing that we've got three zeros in this whole thing, or three roots in this equation, we know that if there's three positive ones, there's no negative ones, then there can be no imaginary ones. If there's one positive one and no negative ones, then there have to be two imaginary ones to get the total of three in each row, right? So we've got the total of three in each row. All right, so the next thing that we're going to do is use this information to kind of guess and figure out what we can do. So we're going to use synthetic substitution, which means kind of a synthetic division to see what the roots could be. So your text suggests saying, hey, check the value, use synthetic substitution to see what happens when you plug in for x a variety of numbers, and let's keep them positive. And so we start 1, 2, and 3. We keeping them positive because if we keep them positive, right, we know that there are no negative answers, and we know that to plug in imaginary answers would be kind of like a whole lot of work. So let's go ahead and plug in a positive one and see what we get. So using synthetic division, I'm going to, or synthetic substitution rather, that's what we call it when we are thinking about it in this way. Make sure I write all the coefficients down with the signs and make sure I put it in descending order. And if there were a missing term here, I'd put a 0 in for it. So if there were no x term, let's say, I would have to put 1, -4, 0 in -5. But since, in -4 rather, since everything is there, we're good to go. Let's drop the 1. 1 times 1 is 1. Add those up, I get -3. Continue the process because I know you remember how to do this. And then I get a +3 here. 1 and 3 gives me 3, and therefore I get -1. So if I were to substitute -1 into this equation, I would get, +1, I'd get -1, which tells me that that's not a 0. So that's okay. I'm going to keep going. Let's try 2. So drop the 1, multiply. Oh, I got to erase all this stuff. My fault, babies. 1, drop the 1, multiply by 2. Add that together, you get -2. Multiply, get a -4. Add that together, you get a +2. Add that together, you get a 4. And then voila, yeah. I don't know, it's supposed to be a happy face. We're happy because we get a 0, and that tells me that we have now found a 0. I can check these guys and see if I have more zeros, but I am feeling like, oh, I'm not checking these. What I'm going to do is use this, what we call diminished or depressed equation, right? Not depressed because it's sad, it's depressed because it is smaller. This referred to a cubic, right? An x to the third power problem. This is going to be an x to the second power because it's diminished. Technically, by substituting that 2 in, we divided out x minus 2. This lets me know that x minus 2 is a factor, okay? X minus 2 is a factor. So let's go ahead and deal with the depressed equation. So we have x squared minus 2x plus 2. And this is the depressed equation that we have. Let me really bring this concept home. We just found out that when I plug 2 in, I got 0 here, which means x minus 2 is a factor. When I plug 2 in, I got 0, which means x minus 2 is a factor. Using synthetic substitution, we found out that it was a factor, but really this was synthetic division. We divided x minus 2 into this function, and we got as a result this function. So that means that x minus 2 times this depressed equation, x squared minus 2x plus 2, is really equal to the original thing that we had in the first place, x cubed minus 4x squared plus 6x minus 4. If I overtalk that and you're like, I'm so bored, just know you can fast forward me. But if it's still not clear to you, we should talk. I want to make this clear. I do want you to understand. So I'm almost done, because remember, I'm looking for the zeros. I'm almost done. I found this guy here, and that's 1 0. How many zeros are we looking for? Just 3. We know either 1 is real and the other 2 are imaginary, or 3 is real and there's no imaginary or any other kind. So what that means is I need to take this last one and set it equal to 0, this next part of the factor. When I set it equal to 0, I'm going to do the work over here, if you don't mind. X minus 2x plus 2 equals 0. I'm thinking about how to solve this. I can't think of a nice way to factor this, because that's always my go-to. I'm going to see if I can factor x minus 1, x minus 2. That gives me 2, but that doesn't give me a negative 2 here. If I try and work it out, it's not going to work. I'm not going to find anything. So what I have to do is solve this equation as it is. How do I solve a quadratic? I solve a quadratic by completing the square or by using the quadratic formula. And I'm going to use the quadratic formula, not that I don't love, and I actually do love completing the square, but I think this is going to be more useful to you in the long run in terms of memorizing something that's going to give you a little bit of opportunity or success later on when you take standardized tests. All right, my darlings, let's do it. X is equal to negative b plus or minus the square root of b squared minus 4ac, all of that over 2a. Let's go ahead and plug in the values that we know, and we have 2 plus or minus 4. Minus 4 times 1 times c, which is 2. All of that over 2 times a, which is 1. So now as I'm simplifying this, 2 plus or minus 4 times 1 times 2, that's 8. 4 minus 8, 4 minus 8. 4 minus 8 is negative 4. Negative 4 tells me I do have 2 imaginary roots. Look at these bad boys looking at me. So I'm going to write it over here, 2 plus square root of negative 4 is 2i over 2, plus or minus, right? Divide 2 into both terms. My 2 answers are 1 plus 2, nope, not 2, sorry about that. 1 plus I and 1 minus I. So my roots are, they asked me to find all of the zeros. So all of my zeros are, I've got 2, and I'm right as 2, 0, right? That's a 0, plug it in. And then I have 1 plus I and 1 minus I. Now, would I write that as an ordered pair? Kind of a weird thing. I don't think I ever thought about that, but I guess we could to say that they're zeros, but they're imaginary, so it doesn't actually cross there, you know? You know. All right. Now we have this last example. This video took longer than I thought. I'm sorry I overtalked that problem. Please forgive me. All right, example 4. Use zeros to write a polynomial function. Write a polynomial function of the least degree with integral coefficients whose zeros are this and this. All right, so here's how you would handle it. First of all, I don't remember if I said it, but I'm going to tell you. Anytime you've got an imaginary root, an imaginary zero, they come in pairs. They come in pairs of conjugates. It's almost like they're frickin' frack. 2 minus I has its cousin 2 plus I. Remember how we used to use conjugate pairs to rationalize the denominator? Well, when you have rational integral coefficients and you have an imaginary root, it has to have its imaginary friend to kind of cancel out the weirdness that'll happen if you only had one imaginary root. So know that they always come in pairs, not just any old pairs, but conjugate pairs. So this tells me the fact that I've got this one imaginary root lets me know that 2 plus I is also a root or or a zero of it, and then 3 is a zero. So how do I write that? Write a polynomial function of least degree. So the least degrees I can have is 3. And so I know I'm going to have something like f of x is equal to x minus 1 term times x minus another term, you guys get where I'm coming from, times x minus another term. I'm using brackets just because they could be parentheses. I just don't mind. It doesn't matter. So I'm using brackets just to separate the parentheses a little bit. So what would I put here? If this is a 0, I'm going to put the number 3. If this is also a 0, I'm going to put the number 2 minus I. And this is a 0, I'm going to put the number 2 plus I. So technically I'm done. I did it. But they want us, if you are asked to do something like that, and integral coefficients, they want to see you multiply the whole thing. So all the coefficients can be integral or integers, right? Integers, number line numbers, negative and positive, whole numbers, integer coefficients. So now we got to do some work. All right, so I'm going to write this as x minus 3. I'm going to leave you back for a second. Watch what I do with this. I'm going to distribute the negative through. I'm going to distribute the negative through. Watch how that looks. So I get x minus a negative 2. Sorry about that. X minus 2 plus I. You see what happened there? And then over here, I'm going to get x minus 2 minus I. And I have done something here that's going to help me multiply. Now, I could just like take my time, multiply each term, but I'm trying to be fancy. So what I see here is x minus 2 and x minus 2. And what I see here is a plus I and a minus I. So in my mind, I see something that is going to help me multiply these two terms. We'll put brackets in here just to help identify what I'm talking about. So this is like a plus b and an a minus b. And I know what a plus b times a minus b is. A plus b times a minus b is going to be a squared minus b squared. So I'm going to get x minus 2 quantity squared when I multiply these two things together minus I squared. I squared we know, and I'm still dragging this x minus 3 along for the ride. Minus I squared rather is going to be a negative 1. So this is going to be minus a negative 1, which is a positive 1. Minus a negative 1 turns to a positive 1. This business here is just a perfect square trinomial. So that's going to be x squared minus 4x plus 4. That's if I FOIL out x minus 2 times x minus 2. Please, please, please know that this is not x squared minus 4. You don't distribute the exponent over subtraction or addition. So now I've done my multiplication here. Do you see how simple that was? And if you're like, no, then you could do it the long way. It's all good. This was like my little shortcut way back in the day. I was like, wait a minute, I don't want to have to do all that work. And looking for patterns sometimes gives you the option to do that. So you notice how I join like terms together here. Now I have a very easy multiplication to happen. I'm going to multiply x through everything, and we're going to multiply negative 3 through everything. When I multiply x through everything, I get these three terms highlighted in orange. Next, I'm going to multiply negative 3 through everything, and I get these terms highlighted in green. So now, of course, you know what we need to do. We need to join like terms together. X cubed is by itself, but an x squared term, I've got two of them, which comes out to negative 7x squared. I'm going to bring my 5x term and my 12x term together to give me a 17x, and I get a minus 15. So here is the polynomial, well, I didn't do it yet, f of x. There is a polynomial function of least degree such that we have these zeros. Cool? All right, make sure it kind of makes sense. Let me know. We can talk if you need a little bit of extra help. Contact me. We can Zoom or go online or do something, find some way to get connected if this is still a little confusing. I look forward to seeing you and talking to you soon. Take care. Bye-bye.